in the computer assignment that you're doing together, I told you that I was going to not teach you how to do a mixed analysis of variance where you have one or more independent variables that are within subjects variables and one or more independent variables that are between subjects variables. And that's true because we didn't learn to do that by hand, but some of you may end up needing that for your work going forward. So I just thought I would show you how to do this. This is an optional video if you'd like to watch this. I can show you how to do a mixed analysis of variance. So let's imagine, if you think back to the in-class assignment that we did, that you were interested in looking at changes in views about the acceptability of teenagers having sex, which is our sex OK variable, as a function of time, and what you wanted to know if those views, those changes over time differed relative to the treatment group that they were in. So what you would do to do that is you would come to analyze general linear model, and you have to go to repeated measures because you have a variable that's repeated measures variable. So as soon as you have one variable that's within subjects, you have to use this choice through the menus. And our time variable has 4 levels, so we're just going to tell the computer that right here. We're going to add that variable, then we're going to define it, then we're going to put in those variables here, and this is exactly like we did it on the in-class assignment that we did together. You're going to stick in sex at time 1, you're going to sex OK, you're going to stick in sex OK at time 2, same thing for sex OK at time 3, and do they think having sex as a teenager is okay at time 4. And then what's different that we didn't do in the computer assignment is that you're going to actually put group in here as a between subjects factor. Okay, so you're going to do similar options to what you did, but now you can see you've got you can get means for the main effect for group, the main effect for time, and the group by time effects. So we'll put that in there. And we need to put compare main effects here because otherwise we don't get those post-hoc comparisons for the within subjects variable. And then you need to put estimates of effect size so that you can report that when you report your results. You hit continue. And then the other thing that you should do is you should come here. I think, you may not need this here for group because I guess you'll get it from that other page. To be honest, I can't remember, but we'll go ahead and ask for it here too, just in case, for that between groups main effect. Okay. And then the other thing that I always like to do is a plot. When I have an interaction, I really like to do a plot. And I always put on the horizontal axis. If I have time as a variable, I always put that on the horizontal axis. If it's not time, then whichever variable has the most levels, I put on the horizontal axis. And that gives me fewer lines. The lines are harder to interpret. So I'm going to add that plot so we can see what the data looks like. I hit continue. I would, of course, hit paste so that I would save this. I'll go ahead and do that so you can see it. So this is what it looks like within subjects factor of time, and it's time by group, and then this is all the stuff that we're asking for. Okay, so we go ahead and highlight that and run it, and this is what the data looks like. Okay, so it tells us here's your within subjects factors, here are your between subjects factors, these are the ends for each of the levels of the group. Okay, as with the repeated measures design, we skip this multivariate test table. We look at the test sphericity, and you can see here this tells us that in this case we do have a problem with sphericity. Since I'm teaching you how to do things the right way, I'll go ahead and we'll bring that to our attention so that we make sure to make an adjustment as needed for the any effects that include time. So if we do the greenhouse geyser effect, then when we look in the test of within subjects, we're going to take the greenhouse geyser corrections, right? Because we violated the sphericity assumption. Okay, so that's what we're going to use. So we'll be reporting these adjusted degrees of freedom. Okay, we won't report the, oh, I'm sorry, we do need this, of course. This is the denominator. This is the main effect for time. This is the interaction effect for time by group. And then this is the error term for both of those. Okay, here's our F. Here's our significance. And you can see that neither of the effects were significant. All right. So you would then, of course, say that there was no significant main effect for time. F with 1.06 and 517.33 degrees of freedom equals 1.42, and then similarly no interaction effect. Then you come down here to find your box that tells you about tests of between subjects effects, and here you'd be reporting these degrees of freedom, and this is also a non-significant effect. Okay. So then down here, this is where we asked it to give us the means for the main effect for group. And here's the pairwise comparisons. You can see there are no asterisks because the effect was non-significant. Here's the main effect for time. Here's the means at time 1, 2, 3, and 4. Pairwise comparisons. Actually, since the overall effect was non-significant, even though there's a star here, which means that it's almost like they did a dependent samples t-test, and one of the pairwise comparisons was significant, but the overall main effect was non-significant. So you're not actually allowed to go in and look at these pairwise comparisons because the overall effect was non-significant. And then the group by time interaction, again, you wouldn't be looking at that. And when you look at the profile plot, actually, this is pretty odd, right? That the learning life skills group went down this much. Maybe that's real, but honestly, it's so different from the others that I would probably go back and just double check my data to make sure that I hadn't accidentally included some sort of missing data, like a -1 variable for a bunch of people or something like that. But if that's real data, then you can see that it looks like there is one group that's getting some benefit. But the problem is that when we looked at the significance, they're all non-significant, right? Unless I made a mistake. Nope, non-significant, non-significant, non-significant. So that difference then is just a chance difference. Okay, that's it. I hope that's of help to you as you think about going forward with your own work.